Hello class, we're about to start section 7.1, Graphing and Functions. Our objectives is to plot points in the rectangular coordinate system, to graph equations in the rectangular coordinate system, use function notation, graph functions, use the vertical line test, and obtain information about a function from its graph. Points in order pairs. In this section we will learn about and use the rectangular coordinate system or the Cartesian coordinate system, named in honor of René Descartes, who developed this idea. He was born March 31st, 1596 in La Haye, Touraine, France, now called Descartes. Died February 11, 1650 in Stockholm, Sweden. He developed analytic geometry. The graphs that we will be using were developed by Descartes. Descartes developed the Cartesian coordinate system. He was also a famous philosopher in his day and time. He is given credit for saying, "Cogito ergo sum," I think, therefore I am. This is the woman responsible for the death of Descartes, Queen Christina of Sweden. She asked Descartes to be her teacher and insisted on early classes. Descartes was in the habit of staying in bed until noon. He developed pneumonia and died. Points and origin. Cartesian coordinate system, a coordinate system developed by the French mathematician René Descartes. It is also referred to as the Cartesian plane, the XY plane, or the rectangular coordinate system. The Cartesian plane is formed by placing two number lines perpendicular to one another. The horizontal number line is the x-axis. The vertical number line is the y-axis. What you see here, this is the x-axis, this is the y-axis. The point of intersection of these two axes is their 0 point, called the origin. Negative numbers are shown to the left of and below the origin. The axes divide the plane into four quarters called quadrants. The four quadrants are numbered using Roman numerals 1, 2, 3, and 4, as we see here. Now our Cartesian coordinates, the first quadrant x and y are positive. The second quadrant x is negative and y is positive. The third quadrant x and y are both negative. And the fourth quadrant x is positive and y is negative. Okay, now one thing that we need to know is this here, which you all learned early on before this course, is that when we're talking about the quadrants, we're talking about the ordered pairs of the quadrants. We're not talking about anything touching the x and y axis lines. So in this quadrant here, x is positive, y is positive. The second quadrant, x is negative, y is positive. The third quadrant, both x and y are negative. And the fourth quadrant, x is positive, y is negative. Now remember, none of these touch the line. Now we scroll down here. Points in order pairs. Every point in a Cartesian plane is located in one of the quadrants or is located on the axis. Each point in the rectangular coordinate system corresponds to an ordered pair of real numbers. Look at the ordered pairs. The first number in each pair, called the x-coordinate, denotes the distance and directions from the origin along the x-axis. The second number in each pair, called the y-coordinate, denotes the vertical distance and direction along the x-axis or parallel to it. The figure shows how we plot or locate the points corresponding to the ordered pairs. Now we have one ordered pair, negative 5, 3. So we start here at the origin. We go to the left 5, which would be negative 5, and then we go up 3 to denote the y, and we plot our point. You always plot the point where your y stops at. So then next, we go back to the origin for this 3, 5. We go to the right 3, where it's 3 and negative 5. We go to the right 3 and down 5 and plot our point. Now, ordered pair, a way to describe a point in the Cartesian plane. It has a pair of numbers separated by a comma. The first number is the x-coordinate of the point. The second number is the y-coordinate of the point. The origin is described using the ordered pair 0, 0. Now we have this example. It says plot the ordered pairs on a given graph. Label the axis and each point that you plot. First of all, we need to label the x and y axis. Remember, this horizontal line is your x-axis. This vertical line is considered to be your y-axis. And then now we can plot our points. We know that this is the origin where they meet at. So now let's plot our points here. Now again, we start here at the origin. X is -3, so we go to the left 3. And then y is 5, we go up 5. And only then do we plot our point. Remember, we only plot our point where the y ends at. Now we go to our next value. We could label this as A, so we know that we plotted A. So we go back to the origin. Now we look at B. B is +4 for x. We go 1, 2, 3, 4. Then y is -2, which means we go down 2. And we plot our point, and that is our B. Now we come here to C. We have -4, 0. We start at the origin. X is -4, so we go to the left 4 places. And then since y is 0, that means we stay here. So this is C. Now we do D. We start back at the origin. X is 0, so we don't move. Or y is 5, so we go up 5. And we plot our point. Now we go to the next, E. Well, actually, I should have marked D here. Now we go to E. We start back at the origin. X is -2, we go 2 to the left. And y is -5, we go down 5. That will give us E. Now we go here to F. We start at the origin. F is 0, 0, which is the origin. So we plot our point here at the origin. So now we're done. Now as you see, some of these points have disappeared. So I will put that back in here so you make sure you put those in your notes. Now, we scroll down. It says example, plot each point in the coordinate plane. Okay, so now we started, well, first we label our axis. This is X, this is Y. So now we start at the origin. We go to the right 3 for X and up 2 for the Y. That'll give us A. Now we go here for B. Start back at the origin. And then we go to the left 3. And then we go down 4. So now that's B. Now we want to go to C. We start off at C here. We'll go to the right 3. Go back to the origin, go to the right 3. And then we go down 1. Remember, that is our C. Now, our next thing, we go here to D. We have D is 2, 0, so we go to the right 2. And since Y is 0, we just leave that point there. And this is D. Now, we go here to E. We have -2, 0. We start at the origin. We go to the left 2. And we go up 3. Now that's E. Now we have F. F, we start at the origin. Since X is 0, we don't move on the x-axis, but Y is -5, so we go down 5. So this is F. Now again, some of these, for some reason, some of these points are disappearing. As you all have your notes, you all can pause this video and copy down where the points are supposed to go. Now, we'll move on to the next problem. Now we have graphs of equations. A relationship between two quantities can be expressed as an equation in two variables, such as y is equal to 4 minus x squared. A solution of an equation in two variables, x and y, is an ordered pair of real numbers with the following properties. When the x-coordinate is substituted for x and the y-coordinate is substituted for y in the equation, we obtain a true statement. The graph of an equation in two variables is the set of all points whose coordinates satisfy the equation. Now, we have a graph of equations point plotting method. Find several ordered pairs that are solutions of the equation. Plot the points, then connect them with a smooth curve or line. Now we scroll on down to the next page. It says graph y equals 4 minus x squared. Select integers for x, starting with -3 and ending with 3. Make a t-table, start with -3 and end with 3. For each value of x, find the corresponding value for y. Now after we do this, we will plot the 7 points that we will get starting from -3 to +3, then join them with a smooth curve. Now what I want to do is scroll down here where we have our solution. Now this solution shows you exactly all of the steps that you are supposed to do. We have our t-table, which we have on the previous page, and then we will substitute in these values for x. We will take this equation and we will use this equation 7 different times using the 7 different values of x to find our y. And this is what we did. We substituted in the values. Now when we substitute in the values, -3 squared, we got -5. When we substitute in -2, we got 0. -1, we have 3. 0, we have 4. 1, we have 3. 2, we ended up with 0. And 3, we ended up with -5. So we wrote our answers as an ordered pair. All of the x values went first, and then our solution here, which is our y value, went second. So now we want to plot the 7 points, then join them with a smooth curve. Now what happened was this here. We took those ordered pairs and we plotted them on this coordinate plane. We had -3, -5, which we know would be down here. We had -3, -5. Next we had that -2, 0. Again, we start at the origin, go over to the left 2. We had -2, 0. Then we had -1, 3. Start at the origin, go over 1, and then go up 3. Next we had 0, 4. Start at the origin, we will go up 4. Then next we had 1, 3. Start at the origin, go to the right 1, and up 3. Next we had 2, 0. We would start at the origin and go to the right 2. And then finally we had 3, -5. We would start at the origin, go to the right 3, and down 5, and plot our point. Now, one other thing I want you to notice is this ends with arrowheads. This means that this goes on forever. And you must end these with arrowheads. If you ended them at the point, it would be incorrect, because that would signify that the graph ends there. Okay, now, it says here, one of the wonderful aspects of the rectangular coordinate system is that it allows us to see formulas and visualize the solution to a problem. Now, we can use what we just learned for this next example. So we read our example here. It says the toll to a bridge costs $2.50. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $21. With the discount pass, the toll is reduced to $1. The monthly cost y of using the bridge x times can be described by the following formulas. Without the discount pass is y equals 2.5x. With the discount pass is y equals 21 plus 1x, or y is equal to 21 plus x. Now we have A, let x equal 0, 2, 4, 10, 12, 14, and 16, and make a table of values for each equation showing 7 solutions for the equation.